Okay, so today we're finally going back to lesson 7B, Intro to Functions. So you know how you've been seeing it say right in the function rule, and they've been asking about functions a little bit here and there. Well, now let's go ahead and put a rule to this. This is what functions are. So students will be able to determine whether a set of ordered pairs, mapping diagram, or a graph represents a function. Students will be able to verbally justify why a relation is or is not a function. So you do need to understand some vocabulary for this. So one that they didn't write in here is the word relation. So go ahead and fill in, and I'll zoom in a little bit. Fill in that a relation just says that every input X has an output Y. So basically that's anything. That's any ordered pair, X and Y. So a relation doesn't really have a rule to it. It just says that every X has to have a Y. So we could have 1, 5, 1, 2, 1, 7. Those are all relations because it's an X and a Y together. So that's the only rule for relations. However, today we're going to be looking at what makes a relation into a function. So it says a function is a pairing that assigns to each input only one output. Assigns to each input only one output. Remember, input is our X values, output is our Y values. So it says every input can only have one output. So over here, I want you to write that again. Function means every input, X, can only have one output for Y. So notice here, I have 0, 1, 1, 2, 2, 3. This would be a function because each of these X's only has one number that it goes to. 0 only goes to 1. Input 1 can only output 2. Input 2 can only output 3. So this would be considered a function where the relation I wrote over here is not. Let me zoom out just a little so that you can see that both at the same time. So this one's not a function. So I'm going to write next to this one in parentheses, not a function, because if we were to try to put this in an equation, input 1 would output 5. And then input 1 would output 2, and then input 1 would output 7. So that means you're inputting the same number and getting different answers every time. So that means that's not a working equation. That's not a function. That's not working. If you input a number, you should only have one output for that number. Okay, so this one would be considered a function. This one would not. And so a little trick to remember this is look for repeating X values. So if you see an X value repeat with a different Y value, then that means it's not a function. So there is a little rule here because these are called relations and special types of relations are called functions. The little rule to remember this, kind of a life lesson and math lesson, please write in, for a functioning relationship, don't repeat your X's. Life lesson, math lesson, all in one. Don't repeat your X's, expecting different outputs. Now, for a functioning relationship, don't repeat your X's. So let's look at what that looks like in math. And we're going to select all of those that represent a function. So let's look at that first list, and we're going to write that as an input and output over here. So we're taking this first list, and we're going to write it down over here. Remember, input is the X, output is the Y. So the first ordered pair is -5, 6. The next one is 0, 8. So I do want you to copy it down. 2, 9, 1, -9, and 0, -3. So this is how easy it is. Look at the X's. So we're not even caring about the Y's right now. Look at the X's. Do you see any of them repeat? Ooh, yes, we do. Draw an arrow. This 0 outputs 8. This 0 outputs -3. So is that going to be a functioning relationship? No. So write not a function, not a function. 0 repeats with different Y's. So that 0 input is outputting different Y values. So that is not a function. No, not that one. No. All right, let's look at the next one. 0, 7. So let's write that in our table. 0, 7. -1, 0. 0, 7. -2, 2. 5, -1. So hopefully you heard me say it when I was saying it out loud. 0 was repeated. But let's look at those outputs. 0 here is outputting 7. 0 here is still outputting 7. So they tried to trick us. They actually put the same number. They just listed it twice. That's okay. That's not going to be two different answers. It just means they inputted the same number twice and got the same answer. So this one is yes. Yes. Function. Nothing repeats with different outputs. So this one is good to go. I'm going to circle that. All right, on to the next one, 4, 6. So let's write it down here. They gave us these little spaces here for our input-output tables, X and Y. So we have 4, 6. I'm just getting the numbers from the top up there. 4, 6, 0, 7, 2, negative 10, negative 4, 8, and negative 4, 8. So again, they tried to trick us. I do see a repeating X, but this X is outputting 8. This X is still outputting 8. So this one is yes. It's a function. So let's go ahead and circle that one. That one's okay. They're really trying to trick you here. All right, let's look at that last one. Negative 2, 0, input, output, X and Y. Negative 2 goes with 0. Negative 2 goes with 2. Negative 2 goes with negative 1. Negative 2 goes with negative 9. Negative 2 goes with 0 again. What in the world? So this is not a function. No, not a function. Why is it not a function? Because this X is repeating with all kinds of different Y's. That's not a functioning relationship. No, not that one. So that's how we can tell. We just look for repeating X's with different Y's. Let's look over here. So here they've actually put it in a nice little input-output table for us already, so we can already see it. We're going to use the space below to kind of see what it would look like on a graph, because they didn't actually give you any graphs here. So let's look at this table. Let's look at all the X's. Negative 3, 3, 4, 7, 16. Did any of these repeat? No, so that's good. That's good to go. That one is a function. What about this one? Ooh, I see a couple repeaters. So let's see, 3 outputs 1, then 3 outputs 4. No, that's a no-go. No. All right, what about this one? Negative 2 and 2, those are different numbers. Oh, here's another negative 2 though. So I see a repeater in the X's. So let's look at their outputs. Negative 2 here is outputting negative 3. Here, negative 2 outputs 8, so that's a no, because they're outputting different values. All right, let's look over here. Any repeaters? Ooh, I do see one. 3 is outputting 1. There's another 3 down here that's outputting 1. But it is the same output. They tried to trick you again, so that one actually is a function. So remember, it's just that every input has to only have one output. So as long as it's tied to the same number still, then we're good to go. So those two are functions. Here's what it would look like on a graph. So let's just graph these first two. So if we draw just a super easy graph, and we were to put these points on it, I'm not going to do 16 because that one didn't make a difference here. But we can roughly see, let's see, negative 3, let's see, looks like it goes up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You should be drawing this too. 5, 6, 7, 8. I'm going to draw it on that one, and I'm going to draw it on the second one as well. And again, this isn't perfect. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So go ahead and draw this in as best you can. Try to make it where it's evenly spaced as best as possible, but obviously these aren't perfect graphs. But I want you to get an idea of what it would look like on a graph. So here we have negative 3, negative 2. Negative 3, negative 2 is here. Then we have 3, 2. Positive 3, 2 is there. Then we have 4, 2 right next to it over here. Then we have 7, 8 up here, and then 16, 10 would be way off the graph. So notice on these, none of them stack up vertically, and so I know none of those X's are repeating, so this one would be a yes. This one is a function. That's just number 1. But look at what happens with number 2. We already know number 2 here is not a function, but what does it look like when we graph it? So we would have negative 3 outputs negative 1. That points right here. Then it says 3 outputs 1, and 3 outputs 4. 1, 2, 3, 4. So that's stacked right above it. Well, we can't be two places at once. Kind of like with our Barbie bungee. Barbie can't be falling 2 different distances with the same rubber band cord. So that's how we know that one's not a function, because these stack up. And so I'm going to put a no with a sad face there, We can put on this other point over here, 7, 8. But the no with a sad face, I'm going to put this vertical box around these so that you can see that's why it's a no. Because, don't mind that bell, because that's why, that's how we can see it's not a function. That's an x trying to be two places at once. Okay, so that's a repeating x. Let's move on to this very last one, a mapping diagram. Now, you might not have seen these before, but that's going to connect every input to an output. So if you want to, you can put them in a table once you see them, and it helps it become a little clearer. So I see 0 goes to 1, 0 goes to 1, 1 goes to 0, 2 goes to 1, 2, 1, and 3 goes to 3. All right, so did any of these repeat? Any of the x's repeat? No, it looks like we're good. So this is a yes and a happy face. All right, what about this one? So our justification, we're just going to make a little table out of it. 8 looks like it goes to -4. -3 looks like it goes to -4. 2 looks like it goes to 2. And 1 looks like it goes to -4. So did any of these x's repeat? No, it looks like it's good to go. It's okay to have the same output. But we can't have a repeated input with different outputs. So as long as the x's don't repeat, then we're good to go. What about this one? Well, hopefully you can already see it because of this weirdness. But here's what it looks like in a table of values. So 9 would go to 1. 4 goes to 1. 4 also goes to 8. 4 also goes to -5. And then 1 goes to 2. So would this be considered a function? No, because we have this repeated x value part that's giving me different outputs. And on a mapping diagram, we can see it because there's a lot of arrows coming out of the same number. And so that would be not a function. That's not a function. Oh, here we are. Not a function. This one is a function, only one arrow. This one is a function, only one arrow coming out of each of those. All right, so there we have it. There's our mapping diagrams. Here's what it would look like on a graph, and there it is on tables. Go ahead and do the exit ticket today and ask me in the back if you have any questions. Have a great day. Yay, math.